short video is going to be on the index of refraction. This symbol that they use is N. N is how the object bends. How much does it slow the light down moving through the material? We demonstrated that light bends as it goes from one material to the other. So if we have, say, a block here of glass, and the laser light comes in and it's incident on the surface, it'll bend and then travel through it. This bending of light, the amount that it is bent, depends on the index of refraction of the material. Whatever that material is, its N value. Okay. For air, or the vacuum of space, the index of refraction is 1. If you have water, the index of refraction is 1.33. So it varies. Another index of refraction is crown glass. And crown glass has an index of refraction of 1.523. Okay? So what that means, for example, if we have the index of refraction, we know it is how light speed changes causing it to bend. You can kind of think about it as when you're driving and the road is wet and rainy and you have a puddle of water on the side and you drive through it with your passenger front tire, it kind of has your vehicle to pull a little towards the passenger side because that tire has been slowed down compared to the other one. So light does the same thing, and we base everything on it based on its speed in the material. And we know the speed of light in a vacuum, that's c, divided by the velocity in the material, that is equal to our index of refraction. So N is equal to the speed of light divided by the velocity of light in the material. And we know the speed of light is 3 times 10 to the 8th meters per second. So, for example, let's say we have a material that has a velocity of light in the material is 2.7 times 10 to the 8th meters per second. What is the index of refraction of that material? So, what do we know? We know C is 3 times 10 to the 8th. We know V is 2.7 times 10 to the 8th. We know N is equal to C divided by V, which is 3 times 10 to the 8th divided by 2.7 times 10 to the 8th, which is 1.11. And there is no units. So the index of refraction for this material is 1.11. Now let's look at light going from air into water. So we know the index of refraction for air is 1. And we know the index of refraction for water is 1.33. We are going to say the ray of light is incident upon the surface of the water at 30 degrees. So that's this angle here. This is your theta 1. And that is 30 degrees. So what angle should theta 2 be? That's what we need to find out. So we know N1 sine theta 1 has to equal N2 sine theta 2. That formula for the entire thing, we know N1 is 1 times the sine of 30 has to equal N2 1.33 times the sine of what we're hunting. Now remember, when you put this in your calculator, the calculator mode has to be set for degrees or you will not get the correct answer. So 1 times the sine of 30 is 0.5, which equals 1.33 times the sine of theta 1, or theta 2, I'm sorry. So now we need sine of theta 2 by itself. So that is the sine of theta 2 is equal to 0.5 divided by 1.33, which is 0.38. So that means the sine of theta 2 is equal to 0.38. Now we want theta 2. To get rid of the sine, we have to take the inverse sine. So that looks like this. Theta 2 is now equal to the inverse sine of 0.38. To get this number on the calculator, you have to hit the yellow second button and then the sine button. And then you should get the sine inverse. So we know theta 2 is equal to the inverse sine of 0.38. So we know that to be, once you put it in the calculator, 22.3 degrees. So our theta 2 is 22.3 degrees. So the light coming in from air hits the water at 30 degrees and it's bent at 22.3 degrees. Now let's look at it. Say we have our ray of light coming in from air and it hits at, let's say, 65 degrees and it bends at, let's go 28 degrees. What are we traveling into? So, what do we know? We know the index of refraction for air, and I always like to call the top, whatever is on top is 1. So this is N1 is air, and it's 1. So N2 is down here, and we don't know what it is. Theta 1 is 65 degrees. Theta 2 is 28 degrees. So we know N1 sine theta 1 is equal to N2 sine theta 2. So we know 1 times the sine of 65 is equal to N2, what we're hunting, times the sine of 28. So the sine of 65 is 0.91. So we have 1 times 0.91 equals N2 times the sine of 28, which is 0.47. 1 times 0.91 is 0.91, and that equals 0.47 N2. We want N2 by itself, so divide both sides by 0.47. So that gives us N2 is equal to 0.91 divided by 0.47, which is equal to 1.94. So our index of refraction is 1.94. So the two main formulas you use in index of refraction problems are N is equal to C divided by V, and N1 sine theta 1 equals N2 sine theta 2.